December 15, 1944. The snow-covered fields outside Bastogne, Belgium. Staff Sergeant Robert Hayes climbed out of his M4A3E8 Sherman tank, nicknamed Iron Mike, and walked slowly toward the hulking silhouette of a German Panzer V Panther that his crew had just knocked out. The Panther's thick frontal armor bore a single penetration hole where Hayes's 76mm gun had found its mark through the tank's side armor during a flanking maneuver. Beside the destroyed German tank sat another Panther, this one intact, abandoned by its crew during the previous day's fighting. Hayes had seen captured Panthers before, had even watched other American tank crews attempt to operate them. What he was about to discover would challenge everything the armchair strategists back home believed about German tank superiority. Within hours, Hayes would be offered the chance to trade his obsolete Sherman for this advanced German war machine. His response would echo the sentiments of American tank crews across the European theater. Hayes kicked the Panther's massive road wheel and shook his head. Despite its fearsome reputation and impressive technical specifications, this tank represented everything wrong with German armored doctrine. In the next 20 minutes, Hayes would explain to his company commander exactly why he and his crew would rather fight the war in their familiar Sherman than in the most advanced tank the Wehrmacht had to offer. His reasoning would reveal the fundamental differences between American and German approaches to armored warfare. The story of why American tank crews consistently chose their Shermans over captured Panthers doesn't begin with a single engagement in Belgium. It begins with two radically different philosophies of tank design and deployment that emerged from the industrial powerhouses of Detroit and the engineering workshops of Germany. To understand why experienced tank crews made choices that seem counterintuitive today, you must first understand what these men valued when their lives depended on their machines performing flawlessly under the most demanding conditions imaginable. When the United States entered World War II in December 1941, American tank doctrine emphasized mobility, reliability, and mass production over individual vehicle superiority. The Sherman tank, designated M4 by the Army, embodied these principles. Weighing 30 tons and powered by various engines depending on the model, the Sherman prioritized mechanical reliability and ease of maintenance over armor thickness or gun caliber. The Sherman's development reflected American industrial capabilities and strategic requirements. Designed for mass production in automobile factories converted to tank manufacturing, the Sherman incorporated simplified engineering solutions that could be manufactured quickly using existing industrial infrastructure. The tank's components were designed for easy replacement and repair using common tools available to any mechanized unit. German tank development followed a different path entirely. The Panzer V Panther, introduced in 1943, represented the pinnacle of German engineering ambition. Weighing 45 tons and mounting a high-velocity 75mm gun, the Panther offered superior armor protection and firepower compared to the Sherman. The tank's sophisticated engineering incorporated advanced metallurgy, precision manufacturing, and complex mechanical systems that reflected German emphasis on technical excellence. The Panther's development consumed enormous resources and required specialized manufacturing facilities that Germany could not easily replicate or expand. Each tank represented months of skilled labor and incorporated components that required precise tolerances and high-quality materials. This approach reflected German strategic assumptions about short, decisive campaigns, where technical superiority would compensate for numerical disadvantages. On paper, the German tank appeared vastly superior to its American counterpart. The Panther's 75mm KWK-42 gun could penetrate Sherman armor at ranges exceeding 2,000 meters. The German tank's armor protection, ranging from 80 to 100 millimeters on the front and 60 to 80 millimeters on the sides, could defeat most Allied anti-tank weapons except at close range or optimal impact angles. The Panther's optical equipment surpassed anything available on American tanks. German range-finding systems, telescopic sights, and periscopes provided superior target acquisition and engagement capabilities. The tank's fire control systems incorporated sophisticated ballistic computers that calculated range, ammunition drop, and target movement automatically. These technical advantages should have made the Panther overwhelmingly superior in tank versus tank combat. In practice, the story proved far more complicated than technical specifications suggested. The first American encounters with captured Panthers occurred during the Normandy campaign in summer 1944. Several tank battalions reported acquiring abandoned or knocked-out Panthers that could be repaired and potentially used against their former owners. Initial enthusiasm among tank crews quickly gave way to frustration as the realities of operating German equipment became apparent. Technical Sergeant Michael Romano of the 3rd Armored Division recorded his experiences with a captured Panther in his personal diary, providing one of the most detailed accounts of American attempts to operate German tanks. Romano's crew had discovered their Panther near Villers-Bocage in July 1944, apparently abandoned after suffering minor mechanical damage that had immobilized the tank during a German retreat. The tank's final drive had failed, a common problem that plagued Panthers throughout their service life. The final drive system, which transferred power from the transmission to the drive sprockets, proved particularly vulnerable to stress fractures under combat conditions. Romano's unit mechanics, experienced in Sherman maintenance but unfamiliar with German engineering practices, spent 3 days learning the Panther's systems well enough to attempt repairs. Romano's first impression of the Panther emphasized its impressive firepower and armor protection. The 75mm gun's high-velocity ammunition could penetrate any Allied tank at combat ranges. The thick armor plating provided crew protection that far exceeded Sherman capabilities. The tank's internal layout reflected careful engineering attention to crew efficiency and system integration. However, Romano's enthusiasm diminished rapidly once his crew began operating the Panther in combat conditions. The tank's weight created immediate problems with mobility and terrain crossing that American crews had not anticipated. Bridges that easily supported Sherman tanks could not handle the Panther's 45-ton mass without reinforcement or risk of collapse. Bridge engineers had to evaluate each crossing point separately, slowing tactical movements significantly. Soft ground that Sherman tanks traversed without difficulty caused Panthers to bog down, requiring extensive recovery operations that exposed recovery vehicles to enemy fire. The tank's ground pressure, despite its wide tracks, exceeded optimal values for many soil conditions encountered in northwestern Europe. Romano's crew experienced multiple instances where their Panther became immobilized in terrain that other tanks in their unit traversed easily. The Panther's mechanical complexity proved even more problematic than its weight considerations. German tanks incorporated sophisticated engineering solutions that required specialized knowledge and tools for proper maintenance. Sherman tanks, designed for operation by minimally trained crews using common tools, could be maintained and repaired under field conditions with equipment available to any American tank unit. Romano documented specific maintenance challenges that made operating captured Panthers extremely difficult for American crews accustomed to Sherman simplicity. The Panther's transmission, a complex 7-speed unit manufactured by ZF Friedrichshafen, required precise adjustment procedures and high-quality lubricants that met specific German military specifications. The transmission's planetary gear sets demanded frequent inspection and adjustment that American mechanics could not perform without detailed technical manuals and specialized tools. American tank units typically carried standardized lubricants suitable for Sherman powertrains, but incompatible with German transmission requirements. The Panther's transmission required specific lubricant viscosities and additive packages that American supply systems could not provide. Attempts to substitute available lubricants resulted in accelerated wear and premature failures that left tanks inoperable far from repair facilities. The Panther's final drive system represented a particular weak point in the tank's design that caused frequent failures under combat conditions. The system incorporated complex gear reduction units that transferred power from the transmission to the drive sprockets. These units operated under enormous stress and required precise manufacturing tolerances that German wartime production could not always maintain consistently. Romano's crew experienced 2 final drive failures during 3 weeks of operation, ultimately abandoning their Panther when replacement parts could not be obtained through any available channel. American supply systems had no provision for German tank components, and captured parts from other destroyed Panthers rarely matched the specific requirements of individual tanks due to production variations and modification changes. Fuel consumption presented another significant challenge for American crews attempting to operate captured Panthers. The tank's Maybach HL-230 engine, while powerful and sophisticated, consumed fuel at nearly twice the rate of Sherman power plants. The engine's 12 cylinders and high compression ratio demanded high-octane gasoline that American logistics systems supplied in limited quantities for aircraft operations. American logistics systems, designed to support Sherman operations, allocated fuel supplies based on Sherman consumption rates and operational ranges. Units operating Panthers required significantly more fuel than standard allocation formulas provided, forcing difficult choices between operational range and ammunition loads. Extended operations quickly exhausted available fuel supplies, leaving Panthers immobilized despite their superior combat capabilities. The fuel quality requirements also created problems for American operations. The Maybach engine required high-octane gasoline with specific additive packages to prevent detonation and engine damage. American fuel supplies, while adequate for Sherman engines, could cause engine damage in Panthers if used for extended periods. Romano noted that his crew had to limit engine operation to prevent damage from substandard fuel. Perhaps more importantly, the Panther's crew ergonomics reflected German design priorities that differed significantly from American preferences and training methods. The tank's interior layout emphasized technical sophistication over crew comfort or operational efficiency. Control locations that seemed logical to German engineers trained on specific procedures proved awkward for American crews accustomed to different operating methods and tactical requirements. Romano noted that the Panther's main gun, while powerful, proved difficult to operate effectively under combat conditions. The gun's high-velocity rounds required precise range estimation and careful ammunition selection to achieve optimal results. Sherman crews, trained on simpler gunnery procedures that emphasized rapid engagement and volume of fire, struggled to achieve accurate fire with the more complex German system, requiring detailed technical knowledge. The psychological pressure of combat made the technical demands of operating unfamiliar equipment even more challenging for American crews. Tank combat required split-second decisions and automatic responses that could only be developed through extensive training and experience. Operating captured Panthers meant abandoning proven procedures for unfamiliar systems that crews could not master during brief familiarization periods. Communication systems in captured Panthers created additional operational problems for American crews. German radio equipment operated on different frequencies and used different procedures than American communication systems. The radios required different antenna configurations and employed modulation systems incompatible with American equipment. Integration into American tank formations required complex coordination that often proved impractical during fast-moving combat operations. The German communication procedures, designed for Wehrmacht tactical methods, did not translate effectively to American combined arms operations. American tank crews needed constant communication with infantry, artillery, and air support elements using standardized procedures and frequencies. Panthers could not integrate into these communication networks without extensive modifications that field units could not perform. The experiences of Romano's crew were repeated throughout American armored units that attempted to operate captured German equipment during the European campaign. Captain James Miller of the 4th Armored Division reported similar problems when his company acquired 3 Panthers during the Lorraine campaign in autumn 1944. Miller's analysis of the captured tanks emphasized the fundamental differences between German and American design philosophies and operational requirements. Miller observed that German tanks like the Panther represented engineering solutions optimized for specific tactical scenarios that differed significantly from American operational requirements. The thick armor and powerful gun proved effective in defensive operations where tanks could be positioned to take advantage of long-range visibility and prepared positions. However, American armored doctrine emphasized offensive operations requiring mobility and reliability over individual tank superiority. The American approach to tank warfare prioritized combined arms operations where tanks worked closely with infantry, artillery, and air support to achieve tactical objectives. Sherman tanks, with their reliable mechanical systems and standardized maintenance procedures, could maintain operational readiness during extended campaigns that covered hundreds of miles over diverse terrain. Panthers, with their complex mechanical systems and specialized maintenance requirements, could not sustain high operational tempos without extensive logistical support. Miller's company conducted comparative trials between Sherman and Panther tanks during a brief operational pause in November 1944. The trials, conducted under controlled conditions with experienced crews, revealed significant differences in operational capabilities that favored the Sherman despite its apparent technical inferiority. Sherman tanks completed assigned missions with 90% reliability rates, while Panthers suffered mechanical failures that reduced mission completion rates to approximately 60%. The maintenance requirements for Panthers proved particularly burdensome during active campaigns where time and resources were constantly limited. Sherman tanks required an average of 2 hours daily maintenance to maintain operational readiness, performed by crew members using standard tools and procedures. Panthers required 6 to 8 hours daily maintenance, performed by specially trained mechanics using tools and parts that American supply systems could not provide reliably. Crew training represented another significant advantage for Sherman tanks in American operations. American tank crews received standardized training on Sherman systems that emphasized practical operation under combat conditions rather than technical understanding of complex mechanical systems. The training focused on procedures that could be executed quickly under stress by crews with varying levels of technical education and mechanical experience. Panther operation required extensive technical knowledge that American crews could not acquire during brief familiarization periods, available during active combat operations. The tank's complex systems demanded understanding of German engineering principles and maintenance procedures that differed significantly from American approaches. Effective operation required months of training that could not be completed while units remained committed to combat operations. Staff Sergeant David Patterson of the 6th Armored Division provided perhaps the most comprehensive analysis of why American crews preferred Shermans over captured Panthers. Patterson's unit operated 4 captured Panthers for 6 weeks during the advance toward Germany in early 1945. His detailed report to division headquarters outlined specific operational factors that made Panthers unsuitable for American tactical requirements and strategic objectives. Patterson emphasized that tank crew effectiveness depended fundamentally on confidence in their equipment's reliability under combat stress. This confidence could only be developed through extensive training and successful operational experience with familiar systems. Sherman crews developed this confidence through months of training and combat operations that taught them exactly what their tanks could and could not accomplish under various conditions. Operating captured Panthers meant abandoning this hard-won confidence for equipment that crews did not fully understand and could not maintain properly without specialized support. The psychological impact of this change proved as significant as the technical challenges. Tank crews facing life-or-death situations needed absolute confidence that their equipment would function when needed most. Sherman tanks, despite their well-known limitations in armor protection and firepower, provided this confidence through proven reliability and familiar operation under the most demanding combat conditions. Crews understood exactly how their tanks would respond to various tactical situations and could predict mechanical behavior with accuracy gained through extensive experience. Panthers, regardless of their superior technical specifications, could not provide this confidence to crews unfamiliar with German engineering approaches. Patterson noted that American tank tactics, developed through combat experience, emphasized rapid movement and aggressive maneuvering that exploited Sherman advantages in mobility and mechanical reliability. These tactics maximized Sherman effectiveness while minimizing exposure to German advantages in armor protection and firepower. American crews had learned to avoid direct confrontations where German technical superiority provided decisive advantages. Operating Panthers meant abandoning proven tactics for unfamiliar approaches that American crews had not practiced extensively. The different performance characteristics of German tanks required tactical modifications that could not be implemented effectively during active combat operations. Crews needed extensive training to develop new tactical procedures that exploited Panther capabilities while compensating for its limitations. The logistical challenges of operating mixed tank types within American units proved insurmountable for sustained operations over extended periods. Tank battalions required standardized maintenance procedures, common spare parts inventories, and uniform training programs to function effectively during rapid advances over long distances. Introducing Panthers into Sherman-equipped units disrupted these standardized systems without providing compensating operational advantages. American tank crews also valued the survivability characteristics that Sherman tanks provided, despite their thinner armor protection. Sherman tanks incorporated design features that improved crew survival during armor penetrations, including easy escape routes and ammunition storage arrangements that reduced catastrophic fire risks. The tank's interior layout provided multiple exit options that allowed rapid crew evacuation when necessary. Panther tanks, with their complex internal arrangements and limited escape options, actually reduced crew survival chances in many combat situations despite their superior armor protection. The tank's ammunition storage, while better protected than Sherman arrangements, created fire hazards when penetrated. The limited escape routes made crew evacuation difficult under combat conditions, particularly when tanks were damaged or immobilized. The Sherman's lower profile and superior mobility allowed crews to employ tactics that avoided direct confrontations with German tanks whenever possible. American armored doctrine emphasized flanking maneuvers, combined arms coordination, and rapid exploitation of tactical opportunities rather than direct tank versus tank combat. These approaches negated German advantages in armor and firepower while exploiting American strengths in logistics and air support. Perhaps most importantly, American tank crews understood that individual tank versus tank combat represented only a small fraction of their actual operational missions. Sherman tanks spent most of their operational time supporting infantry operations, attacking fortified positions, and providing mobile firepower during rapid advances. The Panther's specialized anti-tank capabilities provided little advantage for these missions, while its reduced reliability and increased maintenance requirements created significant operational disadvantages. The infantry support role, which constituted the majority of American tank operations, favored Sherman characteristics over Panther capabilities. Infantry operations required tanks that could operate reliably in close coordination with foot soldiers over diverse terrain conditions. The Sherman's mechanical reliability and ease of maintenance enabled sustained operations that supported infantry advances over extended periods. The winter fighting around Bastogne during the Battle of the Bulge provided the ultimate test of these competing design philosophies under the most demanding operational conditions. American tank units, equipped primarily with Sherman tanks, maintained operational readiness despite severe weather conditions, limited supply lines, and intense combat against German forces employing their most advanced equipment. German armored units, including many Panther-equipped formations, suffered significant mechanical failures that reduced their combat effectiveness during the crucial initial phases of their offensive. The complex mechanical systems that provided Panthers with superior performance under optimal conditions proved vulnerable to the harsh winter weather and supply disruptions that characterized the Ardennes campaign. Sergeant Hayes's experience outside Bastogne typified the American perspective on captured German equipment developed through months of combat experience. When offered the opportunity to operate a captured Panther by his company commander, Hayes politely declined and requested permission to remain with his Sherman. His reasoning reflected the accumulated wisdom of American tank crews who had learned to maximize their equipment's advantages while minimizing its well-known disadvantages. Hayes explained to his company commander that his crew had developed confidence in their Sherman through months of combat experience that could not be replaced by technical specifications or theoretical advantages. They understood the tank's capabilities and limitations through direct experience, knew how to maintain it under field conditions using available tools and supplies, and could operate it effectively under the most demanding combat situations imaginable. Switching to a Panther meant abandoning this expertise for equipment they did not fully understand and could not maintain properly without specialized support that American supply systems could not provide. The risk of mechanical failure during critical combat operations outweighed any potential advantages that superior German engineering might provide under optimal conditions. The crew comfort factors also influenced Hayes's decision to remain with his familiar Sherman. Sherman tanks, while cramped by civilian standards, provided reasonable working conditions for their crews during extended operations that could last days or weeks. The tank's interior layout allowed efficient crew coordination and rapid response to changing tactical situations without requiring extensive retraining or procedural modifications. Panther tanks, despite their larger overall size, actually provided less usable crew space due to their complex internal arrangements and sophisticated mechanical systems. The tank's interior was dominated by technical equipment that reduced crew working space and complicated normal operational procedures. American crews found the German approach to interior design uncomfortable and inefficient for their operational requirements. Hayes noted that his Sherman's mechanical reliability had never failed his crew during critical moments throughout months of continuous combat operations. The tank had operated continuously for 3 months without major mechanical problems, requiring only routine maintenance that his crew could perform without specialized support or external assistance. This reliability record provided confidence that could not be matched by unfamiliar equipment regardless of its theoretical capabilities. The captured Panther showed evidence of multiple mechanical failures that would have left his crew stranded during combat operations far from friendly forces. Hayes observed worn final drive components, transmission problems, and engine irregularities that indicated the tank's complex systems were approaching failure points. Operating such equipment during active combat operations represented an unacceptable risk to crew safety and mission success. The ammunition logistics also strongly favored the Sherman in Hayes' practical analysis. American supply systems could provide unlimited quantities of 76mm ammunition for his tank's gun through established logistics channels that reached frontline units reliably. Ammunition for the Panther's 75mm gun existed only in limited quantities, captured from German stocks, that could not be replenished through any available means. Extended operations would quickly exhaust available German ammunition supplies, leaving the Panther useless despite its superior firepower. American crews could not rely on capturing additional ammunition during combat operations, making the Panther's powerful gun irrelevant for sustained operations. The logistics limitations negated the Panther's primary advantage while creating new vulnerabilities that American supply systems could not address. Communication compatibility represented another crucial factor in Hayes' decision to remain with standard American equipment. His Sherman's radio systems integrated seamlessly with American communication networks, allowing effective coordination with supporting units including artillery, air support, and infantry elements. The radio systems operated on standard frequencies using familiar procedures that enabled rapid coordination during fast-moving tactical situations. The Panther's German radio equipment could not interface with American communication systems without complex modifications that field units could not perform using available resources. Operating a Panther meant accepting communication isolation that prevented effective coordination with supporting elements. This isolation negated many tactical advantages that American combined arms doctrine provided to Sherman-equipped units. Hayes also considered the tactical implications of operating non-standard equipment within his unit's established procedures and formations. American tank formations employed standardized movement procedures, maintenance schedules, and tactical doctrines based on Sherman capabilities and limitations. These standardized procedures enabled effective coordination between multiple tanks and supporting elements during complex operations. Introducing a single Panther into the formation would disrupt these standardized procedures without providing significant tactical advantages that justified the disruption. The Panther's different performance characteristics would require procedural modifications that could not be implemented effectively during active combat operations. The tactical coordination that made American armored units effective would suffer without compensating benefits. The training factor proved equally important in Hayes's reasoning for remaining with familiar equipment. His crew had mastered Sherman operation through extensive practice and combat experience that could not be replicated quickly with different equipment. They could operate the tank effectively under stress, perform maintenance procedures in darkness, and employ tactics that maximize the Sherman's advantages while minimizing its vulnerabilities. Learning to operate a Panther effectively would require months of training that could not be completed during active combat operations. The tank's complex systems demanded technical understanding that American crews could not acquire during brief familiarization periods. Effective operation required expertise that could only be developed through extensive training under controlled conditions with proper technical support. Hayes' company commander, Captain Robert Sullivan, supported his decision and forwarded Hayes' analysis to higher headquarters as an example of practical wisdom gained through combat experience. Sullivan's report emphasized that the American approach to armored warfare depended on standardization, reliability, and mass employment rather than individual vehicle superiority or technical sophistication. Captured German equipment, regardless of its technical merits or impressive specifications, could not integrate effectively into American operational systems that depended on standardization and logistics support. The German approach to tank design, while producing technically superior individual vehicles, created equipment that could not be supported by American industrial and logistics systems during sustained operations. Sullivan noted that American tank units achieved tactical and strategic success through coordinated employment of multiple tanks rather than relying on individual tank capabilities or technical superiority. Sherman tanks, operating in coordinated formations with effective air support and artillery coordination, could defeat German armored formations despite individual technical disadvantages that seemed significant on paper. This approach required standardized equipment and procedures that captured Panthers could not provide without disrupting the systems that made American armored units effective. The integration challenges outweighed any potential benefits that superior German technology might provide under optimal conditions that rarely existed during actual combat operations. The broader strategic implications of the Sherman versus Panther comparison revealed fundamental differences between American and German approaches to warfare that extended beyond individual equipment characteristics. American strategy emphasized mass production of reliable equipment that could equip large formations and sustain extended campaigns over vast distances and diverse terrain conditions. German strategy emphasized technical superiority of individual weapons systems that could achieve tactical success through qualitative advantages rather than numerical superiority. This approach required sophisticated manufacturing capabilities and extensive logistics support that Germany could not maintain during prolonged conflicts against multiple opponents with superior industrial resources. American tank production during World War II totaled over 49,000 Sherman tanks of various models, representing the largest tank production program in military history. This massive production enabled American forces to equip dozens of armored divisions and provide tank support for infantry operations throughout multiple theaters simultaneously. The production numbers enabled replacement of combat losses while expanding armored capabilities continuously. German Panther production totaled approximately 6,000 tanks during the war, insufficient to equip more than a fraction of German armored units with this advanced equipment. The limited production reflected manufacturing constraints and resource limitations that prevented Germany from achieving the numerical superiority necessary for decisive victory against Allied forces with superior industrial capacity. The maintenance and logistics requirements for these different approaches reflected their strategic implications for sustained warfare. American Sherman tanks could be maintained by crews with minimal technical training using common tools and standardized procedures that could be taught quickly to large numbers of personnel. This approach allowed rapid expansion of armored forces and sustained operations far from industrial bases. German Panthers required highly trained mechanics and specialized equipment that limited their operational flexibility and restricted their employment to areas where adequate technical support could be provided. The maintenance requirements created logistics burdens that German supply systems could not sustain during extended campaigns against opponents with superior industrial resources. American tank crews understood these strategic realities and made equipment choices that reflected practical operational requirements rather than theoretical technical advantages. Choosing a Sherman over a captured Panther meant choosing reliability over technical sophistication, standardization over individual superiority, and proven performance over theoretical advantages that could not be sustained operationally. These choices reflected the practical wisdom that combat veterans developed through direct experience with life-or-death decisions under the most demanding conditions imaginable. The crews understood that individual tank specifications mattered less than overall system effectiveness and operational sustainability during extended campaigns. The post-war analysis of American tank operations validated the choices made by combat crews like Hayes and Romano throughout the European campaign. American armored forces achieved their strategic objectives using equipment that many observers considered technically inferior to German alternatives. The success resulted from matching equipment capabilities to tactical requirements and strategic objectives rather than pursuing technical excellence for its own sake. Modern military analysts studying World War II armored operations have identified the Sherman's operational advantages as more significant than its technical limitations in determining campaign outcomes. The tank's reliability, maintainability, and compatibility with American logistics systems enabled sustained operations that German tanks could not match despite their superior individual capabilities. These operational advantages proved more valuable than individual technical superiority in determining overall campaign outcomes and strategic success. The ability to maintain large numbers of tanks in operational condition over extended periods provided decisive advantages that could not be overcome by superior individual tank performance alone. The crew training and confidence factors that influenced Hayes's decision have become central elements of contemporary military equipment selection processes. Modern militaries recognize that crew effectiveness depends as much on familiarity and confidence as on equipment specifications or technical capabilities. The most technically advanced equipment provides no operational advantage if crews cannot operate it effectively under combat stress. The lesson of American tank crews preferring Shermans over Panthers extends beyond World War II to contemporary military operations and equipment selection decisions. Complex, sophisticated equipment that requires extensive training and specialized maintenance may provide fewer operational advantages than simpler, more reliable alternatives that crews can master completely and maintain under field conditions. The psychological benefits of confidence in familiar equipment often outweigh the theoretical advantages of superior technology that crews cannot utilize effectively. This principle applies to contemporary military equipment selection, where operational effectiveness depends on crew performance under stress rather than technical specifications alone. Staff Sergeant Hayes returned to combat in his Sherman tank Iron Mike and continued operations through the final months of the war in Europe. His tank never suffered a major mechanical failure and brought Hayes and his crew safely through campaigns in Belgium, Germany, and Czechoslovakia. The reliable performance validated Hayes's decision to trust familiar equipment over theoretically superior alternatives. The captured Panther that Hayes declined to operate was eventually abandoned when its transmission failed beyond field repair capability during subsequent operations. The tank's mechanical failure proved Hayes's assessment correct and demonstrated the practical wisdom of choosing reliability over technical sophistication during sustained combat operations. The broader implications of Hayes's choice reflected the American approach to warfare that emphasized practical solutions over theoretical perfection or individual technical superiority. American forces succeeded by matching their equipment to their strategic objectives and tactical requirements, rather than pursuing technological superiority for its own sake without considering operational implications. This approach enabled victory through sustained operations that overwhelmed German forces despite individual technical disadvantages that seemed significant when comparing equipment specifications. The American success demonstrated that operational effectiveness depends on overall system performance rather than individual component superiority. The debate over Sherman versus Panther capabilities continues among military historians and armor enthusiasts who focus on technical specifications rather than operational realities. However, the choices made by combat veterans like Hayes provide the most authoritative perspective on the practical advantages and disadvantages of these competing systems under actual combat conditions. Men whose lives depended on their equipment's performance chose reliability and familiarity over technical sophistication and individual superiority. Their decisions reflected direct experience with the realities of combat operations rather than theoretical analysis of technical specifications or laboratory testing under controlled conditions. Hayes's experience outside Bastogne represented thousands of similar decisions made by American tank crews throughout the European theater during the final years of the war. These collective choices reflected a clear understanding of what mattered most in sustained combat operations, where crew survival and mission success depended on equipment reliability rather than technical sophistication. Technical specifications meant less than operational reliability that could be maintained under field conditions. Individual tank superiority meant less than unit coordination and logistics support that enabled sustained operations. Theoretical advantages meant less than proven performance under the most demanding combat conditions that crews would face during extended campaigns. The story of why American tank crews preferred their obsolete Shermans over captured German advanced Panthers reveals the complex relationship between technology and military effectiveness that extends beyond equipment specifications to operational realities. The most sophisticated equipment does not always provide the greatest operational advantage when human factors and logistics constraints are considered. Sometimes, the familiar and reliable proves more valuable than the advanced and complex, when operational effectiveness depends on crew performance under stress. The American tank crews understood this principle and made equipment choices that reflected practical wisdom gained through combat experience rather than theoretical analysis of technical capabilities. That's how American tank crews, through practical experience and hard-won wisdom gained during months of combat operations, chose equipment that matched their tactical requirements and strategic objectives rather than pursuing theoretical technical superiority that could not be sustained operationally. Their choices enabled victory through sustained operations that no amount of individual technical advantage could have achieved alone under the demanding conditions of prolonged warfare.